Hi, my name is Basir. In this video, we'll be working out exercise 10.3 problems. In exercise 10.3, we mostly find out volume of combination of solids. Let me work out the first question. An iron pillar consists of a cylindrical portion of 2.8 meter height. So there's an iron pillar here. Let's say this is our iron pillar. Okay. And this is in the form this is cylindrical in shape. The height is 2.8 meters, so this height is 2.8 meters, and the diameter is 20 centimeter. This diameter complete, that is 20 centimeter. When the diameter is 20 centimeter, the radius will be 10 centimeter, right? Diameter is 20 centimeter, radius will be half of diameter, which is 10 centimeter. So this radius I have it as 10. Now a cone of 42 centimeter height is surmounting it. So above the cylinder, you have a cone of height 42 centimeter. Find the weight of the pillar if 1 centimeter cube of iron weighs 7.5 grams. Whenever you have to find out the weight, you actually first need to find out the volume. Okay? 1 centimeter cube of iron weighs 7.5 grams. First, let us find out the volume of both of these shapes. We have a cone and then we also have a cylinder. Let us find out volume of cylinder first. Volume of cylinder. Volume of cylindrical portion would be, volume of cylinder is pi r square h. Value of pi is 22 by 7. Value of r is given as 10 and the value of h is 2.8. Now this diameter is given in centimeters. This diameter is given in centimeters. But the height is given in meters. So first we'll convert the height into centimeters. We all know that 1 meter is 100 centimeter. So to convert this into centimeters, we have to multiply this with 100. When we multiply this with 100, we get the height as 280 centimeter. So in place of 2.8, I'll just write this thing as 280. So this is 280 centimeter. 22 by 7 into 10 square would be 100 into 280. I'm writing as it is. 7 into 7 4 is 28. 22 into 4 would be 88, and here we have 1 2 3 zeros. So that is the volume of the cylindrical portion. Now we'll find out the volume of the conical portion. Volume of cone is 1 by 3 pi r square h. 1 by 3 pi is 22 by 7. R is, the radius is same here, 10. The radius of the cone is same as the radius of the cylinder, which is 10. And the height of the cone is 42. So this will become 3 1s 3, 3 4s 12, 7 1s 7 2s, right? 22 into 10 square is 100 into 2. 22 into 2 is 44. 44 into 100 is 4400. So what is the total volume of this cylindrical pillar? Total volume of the cylindrical pillar, or total volume of the pillar would be 88,000 plus 4,400, right? So in this cylindrical pillar, you have two parts actually. One is cylinder, and then you have one is a cylinder, and then the second is a cone that is mounted on a cylinder. So to get the total volume, we have to add these two things. Now when we add it, 88,000 and 4,400, when we add it, we get this thing as 92,400. Now in the question it is given the weight of 1 centimeter cube of pillar is 7.5 grams. 1 centimeter cube of pillar is 7.5 grams. What is the volume, total volume that we have? It is 92,400. So this 92,400 will multiply by 7.5. Right. So 92,400 multiplies by 7.5. For just simplification purpose, I'll convert this decimal number into a fraction. After point I have one number, so I'll place 10. If I have two numbers after point, I'll place 100. Right, I believe everyone knows this. Now this 0 and this 0 gets cancelled. 92,440 multiplied by 75. 5 into 0 is 0, 5 into 4 is 20, 5 to the 10, 11, 12, 1, 2, 5, 9s are 45, 46, right? 7 into 0 is 0, 7 into 4 is 28, 7 to the 14, 15, 16, 7 9s is 63, 1, 64. This looks so jumbled. Okay, 6, 6, 12, 1, 13, 4, 8, 9, 6. Okay, so the weight of the pillar is 693,000 centimeter cube. Grams. 693,000 grams. That is the weight. If we have to convert this weight into kg, we'll have to divide by 1000 because 1 kg is 1000 grams, right? So we'll have to divide this by 1000. These three zeros and these three zeros gets cancelled. I get the weight of the pillar as 693 kgs. Let me take a new worksheet here. This one problem actually consumed the complete worksheet. The second question says a toy is made in the form of hemisphere. Okay, the toy is made in the form of a hemisphere, and on this hemisphere you have a cone mounted on it. Right, that okay, this diagram is not so good. Let me draw a little beautiful one. Okay, this should do it. Yes, so a toy is made in the form of a hemisphere surmounted by a right cone. So there is a hemisphere, and above the hemisphere you have a cone. The radius of the base of the cone is 7 centimeter. The radius of the base of the cone is 7 centimeter and its volume is 3 by 2 of the hemisphere. So it's given here volume of the cone is how much? 3 by 2 of hemisphere. 3 by 2 volume of hemisphere. So it's given in the question the volume of the cone is 3 by 2 times volume of the hemisphere, and the radius is given as 7. We have to find out the height of the cone. We have to find out the height of the cone. We don't know this height. Now volume of cone formula is pi r 1 by 3 pi r square h. Right, volume of cone is 1 by 3 pi r square h. Right hand side 3 by 2 I am writing as it is. Volume of hemisphere. Volume of sphere is 4 by 3 pi r cube. So volume of hemisphere would be 2 by 3 pi r cube. Right, this 2 and this 2 gets cancelled. This 3 and this 3 gets cancelled. This pi and this pi gets cancelled. I can actually cancel r square and r cube also. 1 r would be remaining on the right hand side. I can cancel r also because the cone, the base is same for the sphere and the cone. So the radius is actually same for the sphere and the cone. That's the reason I'm cancelling this radius and this radius. Now what do I get on the left hand side? I get 1 by 3 h is equal to, everything else is cancelled out, I'm getting r, the value of r is 7. So the value of h is 7 into 3, right? 3 is dividing on the left hand side, so 3 will multiply on the right hand side. So the value of h is 21. Value of h is 21. So this value here is 21. So they wanted us to calculate the height of the cone. And then they also want us to find out the surface area of the toy correct to 2 places of decimal. Take it. If we have to find out the surface area, we have to find out curved surface area of the cone, and then we also have to find out curved surface area of the hemisphere. First, let us find out curved surface area of cone. We know that curved surface area of cone is given by the formula pi RL. We don't know L first. We don't know the slant height. So first we'll find out slant height. L square is R square plus H square, right? So L square is R is how much? R is 7 and H is 21. Here R is 7 and then H is 21. So L square would be 49 plus 441 square would be 221 square would be 441. L square would be 441 plus 49 is how much? Is 490. L will be, if I remove square from the left hand side, I'll have to put a square root on the right hand side. L is 490. I can write it as 49 into 10. 490 I can write it as 49 into 10, right? This root will go for 49 also. This root I can distribute to 10 also, because everybody knows root of AB is root A into root B, right? Square root of 49 is 7. 7 into root 10. So I am getting the length as 7 root 10. What is the value of root 10? Let us find out the value of root 10 here. How do we find out the value of root 10? We can use the division method to find out the value of root 10. I'll pretty much do it here. Let me find out the value of root 10 here. I'm not going to explain you this division method, because this division method is something that you guys learned already in the previous classes. I'll just find out the square root for you directly. If you want to learn how to find out square root using the division method, then I will pretty much create a separate video for it. Okay, so I'm just taking the value of root 10 as 3.16 roughly. So it has to be 3.16. 3.16 into 7 will give you the slant height. 7 into 6 is 42. 7 1 is 7. 7 plus 4 is 11. 7 3 is 21. 21 plus 1, 22. So the value of L is 22.12. Let me now find out the curved surface area of cone. Pi value is 22 by 7. The value of R from the cone is 7. And then the value of L is 22.12. 7 and 7 gets cancelled. 22.12 into 22 is how much? 4244. 4244. 46684. Right? So it is 486.64. That is the curved surface area of That's the curved surface area of the cone, and the units are in centimeters, so this would be centimeter square. Now I found out the curved surface area of cone. Let me now find out the curved surface area of hemisphere. Curved surface area of hemisphere. These problems are very easy. It's just that these problems are a little lengthy. Too many calculations are involved here. But these problems, trust me, are kind of very easy. Curved surface area of hemisphere. Curved surface area of hemisphere is 2 pi r square, right? Curved surface area of hemisphere is 2 pi r square. 2 into pi is 22 by 7. The value of r, what is the value of r here? The value of r is nothing but 7 here, right? So I'm going to substitute the value of r as 7. 2 into 22 by 7 into 7 square is how much? 49. 7 sevens are 49. 2 into 22 is 44. 44 into 7 is how much? 7 4s are 28. 7 4s are 28. 29 30. 308. 308. 308. Curved surface area of hemisphere. That's a hemisphere, right? Curved surface area of hemisphere is 2 pi r square, and the value of r is 7. The value of r is 7. That's right. Take it. Now, what is the total area of this solid? The total area of the toy. The total area of the toy should be curved surface area of cone plus curved surface area of hemisphere. Curved surface area of cone, I got it as 486.64. 486.64, and then this I got it as 308. Let me add them up. 308. So that is 794.64 centimeter square. Let me take a new worksheet here, or else I believe I can pretty much do the third one here itself. The third question says, find the volume of the largest right circular cone that can be cut out of a cube whose edge is 7 centimeter. So there's a cube here, and the edge of the cube is 7 centimeter. We are trying to cut out a largest possible cone from this cube. From this cube, we are trying to cut out a largest possible cone. The largest possible cone that can be cut out from this cube would have a diameter which is equal to the side of the cone. So the diameter of the cone will be equal to actually the side of the cube, which is 7. Diameter would be 7 centimeters. So radius will obviously be 7 by 2. And the height of the cone, the height of this cone will also be equal to the length of the side of the cube, which is again 7. So the height of this cone will also be equal to 7. You just have to find out the volume. Volume of cone is 1 by 3 pi r square h. You know the value of r here. You have the value of h. I'm sure you can find it on your own. Okay. So this thing, try it out on your own. I have already given you the hint. The largest possible cone that can be cut out from this cube will have a diameter which would be equal to the length of the side of the length of the edge of the cube, and it will have a height which will again be equal to length of the edge of this cube. Okay. So r would be 7 by 2, h would be 7. Use the formula for finding the volume, which is 1 by 3 pi r square h, and find out the volume of a cone. Question number 4 says a cylindrical tub of radius 5 centimeter and length 9.8 centimeter is full of water. So first things first, let me draw a cylindrical tub with a radius of 5 centimeter and length 9.8 centimeter. cylindrical tub. Let's say this is our cylindrical tub. Yes, that's our cylindrical tub with a radius which is equal to how much? The radius is 5 centimeter, 5 centimeter, and the length of the cylinder is 9.8. Length of the cylinder is nothing but the height of the cylinder, right? So the height of the cylinder is 9.8 centimeter. A solid in the form of a right circular cone mounted on a hemisphere. There is a solid which is in the form of a cone mounted on a hemisphere. So that's a cone here, uh, which is mounted on a hemisphere. That's my hemisphere, and then this is my cone. So the cone is mounted on a hemisphere. That is the shape of a solid. That solid has been immersed into this tub. This solid is immersed in the tub. It already says that this tub, cylindrical tub, is full of water. When you immerse this solid in this cylindrical tub which is full of water, the water will spill out from this cylindrical tub, right? The water will spill out. We have to find out after the water spills out how much water is remaining in this cylindrical tub. It's very easy to find out. The volume that the quantity of water that spills out from the cylindrical tub will be equal to volume of the solid that is being immersed. So to find out the remaining water, you just have to subtract the you just have to do this volume of cylinder minus volume of this solid. That will give you the remaining water, right? It's kind of simple. ठीक है. First things first, we will find out the volume of the cylindrical tub. Volume of the cylindrical tub. The volume of the cylindrical tub is given by the formula pi r square h. Volume of a cylinder is pi r square h, right? Value of r is 5, the value of h is 9.8. So 22 by 7 into 5 square is how much? 25. 25 into 9.8. 7 1s are 7. 8 9 2 is remaining. This becomes 28. 7 4s are 28. For simplicity purpose, let me just convert this into a fraction. 1.4 I can write it as 14 by 10. 5 2s are 10, 5 5s are 2 1s are 2 7s are 22 into 5 is 110, 110 into 7 is 770, right? 110 into 7 will be 770. 770 centimeters cube. That is the volume of cylindrical tub. Now let us find out the volume of this toy. The radius of the hemisphere is given as 3.5. The radius of the hemisphere is given as 3.5, and the height of this cone is given as 5. So we'll find out the volume of this toy. Volume of the toy. Volume of this toy will be equal to volume of conical part plus volume of the hemispherical part, right? If I have to find out the volume of this toy, I'll have to find out the volume of cone, and I'll have to add it to the volume of hemisphere. Now volume of cone is given by the formula 1 by 3 pi r square h, and the volume of hemisphere is given by the formula 2 by 3 pi r cube, right? Volume of hemisphere is 2 by 3 pi r cube. For simplicity purpose, I'm just taking common from both of these terms. I am taking 1 by 3 pi r common, because here you have in the first term 1 by 3. In the second term also you can take 1 by 3 common. Pi and pi, you can take pi common. R square is in the first term, r square I can take common. Okay, so 1 by 3 pi r square I took common. I'll be getting h here, And what can I do here? 1 by 3 pi r square I took out, so I'll be getting 2r here, right? 1 by 3 pi r square I took out, so I'll be getting 2r here. Now let me substitute the values here. The value of pi is 22 by 7. The value of pi is 22 by 7. The value of r is, what is the value of r here? R is 3.5 and height is 5. R is 3.5 square, I'm writing as it is. What is the height here? Height is 5. R is 3.5. So 1 by 3 into 22 by 7 into 3.5 square would be 12.25. 3.5 into 2 is 7, right? 1 by 3 into 22 by 7 into 12.25 into 5 plus 7 is how much? 12. 3 ones, 3 fours, 7, yeah, it goes in 7 table, right? 7 ones are 7. How much is remaining? 5, 52. 7 sevens are 49. 3 would be remaining. 7 fives are 35. So how much I'm getting here? 1.75. 22 into 1.75. I can convert this into fraction. If I remove point here, I'll have to place 100 because after point we have two decimal numbers, two decimal places. 25 fours, 25 sevens, right? 25 sevens are 125. 4 and 4 gets cancelled. 22 into 7 is how much? 154. So the volume of this solid, which is a cone mounted on a hemisphere, volume of that solid is 154 centimeter cube. And after we immersed this solid in the cylindrical tub, water spilled out, and we have to find out how much water is remaining. How do we find out the remaining water? We have to subtract the volume of this solid from the volume of cylindrical tub. The volume of cylindrical tub is 770. From that I have to subtract the volume of the solid which was immersed in the cylindrical tub. So this gives me 616. So volume of water that is left out is 616 centimeter cube. Water which spilled out, it is 154 centimeter cube. Water that spilled out from the cylindrical tub will be equal to it will be equal to volume of the solid that is immersed. So 154 centimeter cube water spilled out. The total water previously was 770 centimeter cube. 154 centimeter cube spilled out. So the remaining water is 616 centimeter cube. I hope this thing is clear. Fifth one, I'll just give you a hint. I'm sure you can do it on your own. Fifth one, the diagram is given on the right hand side. In the adjacent figure, the height of solid cylinder is 10 centimeter and diameter is 7 centimeter. So the diameter here is given as 10 and the height is given as 10. The diameter is 7. Two equal conical holes of radius 3 centimeter and height 4 centimeter are cut out as shown in the figure. Find the volume of remaining solid. Volume of remaining solid is simple. You have to find out the volume of cylinder first, and from that you have to subtract volume of both of these cones. When you subtract the volume of both of those cones from the volume of the cylinder, you will get the volume of the remaining solid. That is your hint for this question. Spherical marbles of diameter 1.4 centimeter are dropped into a cylindrical beaker of diameter 7 centimeter, which contains some water. Find the number of marbles that should be dropped in the beaker so that the water level rises by 5.6 centimeter. I've already drawn the figures here. This is a spherical marble which has a diameter of 1.4 centimeter, which means the radius would be half of it, which is 0.7 centimeter. Now these spherical marbles are being dropped into a cylindrical beaker, and the diameter of this cylindrical beaker is given as 7 centimeter, which means the radius would be 7 by 2. After we dropped the spherical marbles, the water level it rises to 5.6 centimeter. Now we have to find out how many marbles were dropped into the cylindrical beaker. This is quite simple. Number of marbles that were dropped we can find out by using this. We have to divide the volume of this cylindrical beaker by the volume of spherical marble. Volume of cylinder is pi r square h. You know the value of r, you know the value of h. H is 5.6. Volume of spherical marble is given by the formula 4 by 3 pi r cube. You know that the diameter is 1.4, so the radius is 0.7. Substitute the values and find out the number of marbles that were dropped in this cylindrical beaker. So this is your assignment for the day. I believe I gave you quite a number of problems to work on. Seventh one also I'm not going to do it. It looks like I became a little bit lazy now. The time right now is 3:30 a.m. So I'm just preparing this video in the night. Feeling almost sleepy, but I'll give you a hint to work on exercise. Work on the seventh question. It says that a pen stand is made of wood in the shape of cuboid with 3 conical depressions to hold the pen. So this is a wooden stand, and in this wooden stand you have 3 conical depressions that are made to hold the pens. After we made out the conical depressions, we have to find out what is the wood in the entire stand. This is pretty simple. You have to subtract the volume of wood that was taken out by carving out these conical depressions. Subtract that from the volume of the cuboid. In other words, let me rephrase it. Volume of the cuboid minus volume of these 3 cones will give you the volume of the wood in the entire stand. Let me repeat it. Volume of the cuboid minus volume of these 3 conical depressions will give you the volume of the wood in the entire stand. That's your hint for the day. You can do it on your own. In the next video, we'll be working on exercise 10.4, which is the last exercise in this chapter. And this in the next exercise 10.4, we would be dealing with conversion of solid from one shape to another. See, when one solid is converted into a different shape, we observe that the volume of both of those solids remains same, which means, let's say this cylinder has a volume of 64 centimeter cube. Okay, the volume of water in this beaker is 64 centimeter cube. I pour the water in a cubical this thing. Then the volume of water here would also be 64 centimeter cube, right? So when one shape is melted and casted into another shape, the volume of the new shape would be same as the volume of the previous shape. You will understand it in more detail when I explain you problems from exercise 10.4. I'll see you all in the next video. Until then, goodbye.